FusionFabric.cloud dataset allows us to receive a copy of a series of datasets and have them pushed directly to a specified blob storage container. In our case, we've used FusionFabric.cloud dataset to receive a copy of the customer loans and customer demographics CSV file. We'll be using Python to analyze this data, look at the statistical characteristics, build a few visualizations, and finally build a neural network deep learning model to predict if a loan will be accepted or denied. Let's open a Jupyter notebook and get started. Here we have the imports we will be using. We will use pandas and NumPy for data handling and manipulation, SciPy for some statistical analysis, Matplotlib and Gmaps for plotting and visualization, and sklearn and Keras for machine learning and deep learning. Here we load the customer loan and demographic data. Our customer loans data has columns such as customer ID, debt, interest rate, credit incidence, home value, loan amount, product type, and loan status. Our customer demographics data has columns such as name, job, age, latitude, longitude, income, credit score, household size, and more. Next, we will see if we have any missing data. We see that there are no columns that contain null values. We then check all of our numerical columns to see if there are any outliers beyond 3 standard deviations. Doing so, we see that we have no outliers in our dataset. It seems our dataset's pretty clean. We can now look at the descriptive statistics around the 2 datasets we pulled from FusionFabric.cloud dataset. We get a count, mean, standard deviation, min, max, and a few quantiles across our numerical columns. We also plot a histogram so we can see the distribution of the data. Let's now spin up a heat map showing the location of our customers based on latitude and longitude. It seems there is a higher density towards the northeast and a few dense points towards California. We've examined our individual datasets briefly, so let's now join them together. We have data such as income, credit score, debt, loan term, interest rate, age, household size, and more. Let's use some of these columns as features and do some one-hot encoding on some categorical product type data to create our base feature set. Our target variable will be the column called loan status, which takes on the values approved or denied. We will build a neural network classifier that will predict approved or denied based on our input features. Since we're building a neural network, we will scale our data. We can leverage the min-max scaler from sklearn for this. The following function called createModel will build a feed-forward neural network for binary classification. The function train and evaluate model will train the network and return us the validation accuracy when we do our k-fold cross-validation. K-fold cross-validation trains and tests the model with every data point in the train and test set. We will use 3 different splits and train the model and look at the estimated accuracy across the runs. After the model trains, we see that the estimated accuracy was approximately 94%. This is pretty good, so we'll use this model. We will retrain the model with more train and test data and fit our final model. We now plot the loss for the train and test set as well as the accuracy for the train and test set. The metrics look good. Using FusionFabric.cloud dataset, we've accessed 2 datasets, pulled them into a Jupyter notebook, examined our data, visualized it, and built a deep learning classification model.